For the next part of this lecture, we're going to be talking about divided attention. Divided attention is the skill of performing multiple tasks simultaneously, and in everyday language, this is commonly referred to as multitasking. Now, divided attention is easier when the two actions you're involved in, or potentially more actions you're involved in, are quite different from each other. For example, it will be easier to eat food and listen to the radio and actually understand what the radio is saying and enjoy your food than it would be to read a lecture at the same time as listening to a radio. I don't just mean like an instrumental on the radio, but I'm imagining like a talk show or something. So the reason for this is when you're reading something and you're listening to a talk show, both of those things involve language and thus both need to be processed by a similar region of the brain. And this creates a bottleneck because now two different independent things need to be processed via only one single place. And ultimately what will happen, even though you're able to still do it, is this region now will continually be switched back and forth between the different processing streams, and this will ultimately slow down and impair performance. Whereas when one is eating while listening to the radio, here your eating is an entirely different set of neuronal resources being involved. You have various motor activities while you're chewing, along with olfaction and gustatory senses for processing what is in the food itself. While when you're listening to the radio concurrently, that is traveling through your ears via temporal cortex into your language processing centers, and it's just occupying an entirely different region of the brain. And so these two are able to ultimately function in parallel without interfering with each other, and so they cause much less interference in performing these two different tasks. Now, the degree to which neuronal resources involved in multiple tasks are common is what dictates how similar or different those two tasks are. The greater the overlap of neuronal resources, the more similar they are, and the greater impairments we would find in divided attention. The more different or the less overlap of neuronal resources that one finds, the more easy or the less impairment we will suffer from divided attention tasks. And ultimately, the more different the tasks, the easier they are to perform together. Here's just an empirical demonstration to show this. So Allport, Antonis, and Reynolds in 1972 on divided attention, they were showing how you can do multiple different things at the same time, but depending on what combinations of things you're taking part in, your performance will tend to degrade. So the way this experiment works is participants were presented with a list of items, and they could be one of three lists that were presented to these participants. The first was they were presented a list of words through the auditory modality, meaning they heard them. Others could have seen a list of words presented on a computer screen, and finally a third set saw a sequence of pictures also presented on a computer screen. Now, the whole time in which they were looking at one of these three lists, they were also listening to an alternative audio stream. So here you can imagine you're looking at the pictures while you have headphones on and you're listening to this auditory stream. For looking at the words on the computer screen, you're listening via headphones to one channel while you're looking at the words on the computer screen. For the list of words presented via audition, here one channel of the headphone is playing the list while the other channel is playing the audio stream that is presented consistently across all of these. At the end of this task of them being presented the list of words, they were told that this is actually a memory task, and they wanted to test how well people would be able to remember the items that they had just been exposed to. So for the first two, it is words, and for the third, it is pictures. Now, they weren't asked to just recall all the ones they had seen, but rather they were shown sequences of words or images and asked whether or not that was present in the previous list that they had been shown. Looking at this set of bars here, you can see that this y-axis is representing the number of errors that people made, and it's likely in percentage, but it could be that they actually showed them this many items that one could make so many errors. Now, when they heard the words along with the other audio stream that was unrelated, you can see that they made an incredible amount of errors in the number of words that they remembered from that original list. This, of course, decreases when the words in the list are presented visually. Right? The difference being here that even though both are using the language centers of the brain, one now is being processed via the visual system, whereas here both are required to be processed via the temporal and auditory cortices. You get even less errors when it's pictures, because here the crossover is minimal at best. Here, your items that are to be remembered are visual entirely, while the audio stream that is being processed in the temporal cortex has very little interference and impact on which of these particular pictures one is remembering. Of course, there is a non-zero number of errors, which could either be because of some cost of divided attention, or because some people just tend to make errors. The biggest thing to take away from here is that the more different the two sets of stimuli are, the easier it is to recall individual instances within those sets of stimuli. So from this, despite I'm sure what many people will hear and debate about whether multitasking is possible or not, it is possible to divide your attention. And while it is possible to do so, and in some cases it's easier to do than in others, there's pretty much always a cost to performing more than one action at a time. And this is likely due to the fact that there are some neural networks or neuronal networks that are involved in almost all actions, regardless of what type of action that is, be it processing of any of the various sensory modalities or engaging actions along really any of the ways in which we can engage actions. We call these things general resources or common resources across tasks. Here are just some various examples of previous studies that have looked at this. So here is looking at differences in driving when one is talking on a cell phone or not. And please note that this is just talking via a speaker on a phone. You're not actually texting or looking at the screen in this case. The y-axis for this graph is representing a fraction of red lights missed. So this is in a proportion from 0 to 1. So this proportion of 0.03 about indicates that people miss every 3 out of 100 traffic lights that they go through, which is an alarming number of traffic lights to miss if you think about it. When there's a phone present in the car that they're using to speak on, you can see that this number of missed traffic lights jumps by almost double. In fact, a little bit more than double, where we are now at a proportion of 0.07, meaning now on average about 7 out of every 100 traffic lights are being missed, or just one is oblivious to them. So even though driving uses a rather musculature and visual system to operate on, and speaking tends not to use those to a large degree, being primarily through language and audition, you can see that there is still a cost involved when one is engaged in an additional activity. This middle graph shows much the same information, except they're looking at the reaction times that people have in their ability to initiate a stop when they're required to because of something present in their visual field. Now, here you can see that it takes people on average about 525 milliseconds to initiate a response to stop. Well, that goes all the way up to about 575 milliseconds here. Now, while this might not seem like a large difference, and in a time sense it is not, if you are traveling at about 80 miles an hour, this will equate to about 7 feet of stopping distance. If you've ever been in a close call where you've had to stop quickly right behind the bumper of another person, oftentimes 7 feet can make a world of difference. Finally, this third graph is showing how easily people can navigate through a complex driving sort of shall we say, puzzle, task, arena, whatever you could make that's complex to have people drive through that's not actually dangerous. So like a driving training session. And here you have how well they're able to go through it, the number of success rates on the y-axis, and you see that when one is driving with a passenger, having a conversation with them, the success rate of this is much higher than when one is driving while having a conversation on a cell phone, even if the conversation is pretty much the same. The reason for this finding is that when one has a passenger in the car, they too are aware of the surroundings in which they are ultimately existing. with the driver alongside. So when they notice that conditions are perilous, it starts to rain or hail, or there's a complex intersection to move through, or it just looks like the driver is stressed out by some situation. Oftentimes, most passengers will stop talking to the driver and let them get through the situation until they can calm down and the outside world becomes more relaxing. Whereas when a person is on the telephone, they're oblivious to these cues for the most part, as they're not currently present in the same situation, and they continue to maintain their conversation and thus distract the driver from their driving. Even though the driver can pay attention to both things, their effectiveness is ultimately impaired. Speaking of those general resources, we'll talk about two of them. The first is this idea of a response selector. So it's important to know that this response selector is just hypothesized. We've not identified a singular space in the brain or a specific structure that's associated with this type of action. If you want more about actual specific brain regions, you can look into the basal ganglia, as it is considered to be something that might be involved in this and is currently a good candidate. Anyhow, this is considered to be needed for the selection and initiation of pretty much any type of response, be it overt responses, meaning something you do with your body that can be seen by others, you move your hands, you move your mouth, something like that, or covert responses, which are just thoughts about things, where I could say something to you and you just have a thought, but you don't tell me or show any expression. Nonetheless, that is an initiation of a response in response to a cue, me saying something. Okay, this is ultimately involved in pretty much selection and initiation of any kind of potential response you could have. And because you are looking at selecting and then also inhibiting various responses, that pattern is present in everything you would do. You are deciding as you are driving how much to press on the accelerator, when you're likely to make turns, how to tense your arm muscles depending on where your position is on the steering wheel. There are many, many actions that go into it. And the same is true for speaking on the phone or just speaking in general. Not only do you have to move your mouth and all of the muscles involved in creating speech, but there is this tremendous amount of initiation required to choose what are the next words that are likely to come out of your mouth. And that is actually an unbelievably complex set of mechanisms that we'll talk much more about when we get to language. The other general resource is executive control. Now, this is something one talks about all the time. It's oftentimes considered one of the hallmarks of human beings and what makes us amazing and blah, 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 blah. Specifically, this is the mental resource that ultimately is used to set goals, to change and choose priorities, and also to avoid conflict between either now multiple goals that are competing for our attention, or to have and resolve conflict between our current habits and the situation we find ourselves in, and whether those behaviors would be adaptive or not. It is oftentimes considered to have three primary functions. The first is to maintain current goal state. This is where it is ultimately helping you not get distracted, is what we mean by maintaining current desired state. If you need to study and you only have a few hours and you have a lot of work to get done, you have to maintain on that studying to do, else it is easy to get distracted by other things, one's hunger, one's desire to go outside, one's desire to play catch or read a book, or anything else for that matter. And the ability to maintain and stay on task is oftentimes considered to be handled by this resource. Further, it ensures that the mental steps required to achieve a goal are organized in the correct sequence. Most of the initiation of actions that we will impart or engage on in our lives tend to be multi-step processes. Everything from moving your hand to pick up a cup involves a large degree of sequence of moving muscles to do so, all the way to making a plan that lasts for a year or more. In each of those cases, there are many, many steps required to get from where we are right now to the end state of our goal. In order to have the correct sequence in order to get there, this resource is thought to be needed. Because after all, you cannot build the roof of a house before you have built the walls. In this same way, there are certain limits on what we can achieve because it requires previous achievements in order to move forth with the ones in the future. Finally, it is thought to help in inhibition of automatic processes. These are when you have built up habitual responses that are not always adaptive in certain situations, that you are thought, or this is required in order to inhibit the action of those automatic processes. An example of this would be, let's say you were raised in a situation in which prejudice was very common. It was never told to you to be something of a negative valence situation, and you grew up your entire life thinking ultimately negative thoughts about an entire group of people. Now, whether you care to admit it or not, when you're in future environments, those are often going to be the first thoughts that pop into your mind. In order to begin changing those and readjusting that sequence of thoughts and perhaps even discriminatory behaviors, one needs to be able to limit and inhibit the automatic response of those prejudicial thoughts. And for a large degree, we believe that the resource of executive control is heavily involved in this type of process as well. This is why people who suffer tremendous damage to this region of the brain, or we'll talk about the PFC in a second, and that region of the brain, which is exemplified with Phineas Cage, where he was no longer able to prevent himself from having various either violent or inappropriate outbreaks. It was because one had this urge or habit to say something or do something, and then was not able to inhibit those automatic responses. Now to get to the relationship between executive control and the PFC. So the PFC stands for the prefrontal cortex. This is the part of the frontal cortex that is right behind the eyes. And this is heavily involved, at least believed to be involved, in the executive. Though there's still a lot of debate about how neuronal tissue can actually instantiate this degree of control and goal maintenance. Now, we believe that it is related to the executive from two very specific types of errors that people tend to make when this brain region is damaged. Those are perseveration errors and goal neglect. Now, perseveration errors refer to the tendency to produce the same response over and over, even when it is plain that the task requires a change in response. So an example of this is if you're in the middle of a task, say sorting cards by number or by shape, right? Squares go here, circles go there, triangles go there. And then halfway through you're told, okay, stop sorting them by shape. It's time to start sorting them by color. Red ones go here, blue ones go there, yellow ones go there. People with damage to the prefrontal cortex will have an incredibly difficult time switching that instruction once they've learned the new one. Many of them will continue to just keep sorting by shape, even though you've told them to switch to sorting it by color, and you can tell them this repeatedly and they will not update their behavior. And they will just keep having the same response over and over. It ultimately goes to show that once a pattern is ingrained, it becomes very difficult to change this when one has suffered damage to the prefrontal cortex. When it comes to goal neglect is the inability for people to keep their mind on some kind of specific goal or target. They get distracted and then they ultimately just pursue their whimsy. You could think of this as an extreme and utter case of not being able to focus for any extended period of time. An example is given here of how this can be shown. So here are two participants who have suffered, I mean, they're not technically participants, I guess, but, well, kind of. Anyway, never mind. Both of these people have suffered damage to the prefrontal cortex. Their task was to look at this image is presented to them, it is sitting in front of them, and they're asked to copy this image. Now, here for this one, they actually do a fairly decent job. But if you really look closely at how they've drawn this, they don't seem to have the same or appropriate structure as a person would to draw such a shape. After all, wouldn't you try and draw this rectangle first, easily chop it into these 8 slices so you could fill them in and then add the various small details after to ensure an accurate copy? Which would be the easiest thing for many people to do, while over here you can see that that's not actually what happened. All of these various regions have sort of been added in an ad hoc manner, slowly as they carry on. Not to mention, it is still not perfectly represented. And now, by perfectly represented, I don't mean they need to be super artistic that they could create this, but remember, this is a relatively simple line drawing that is in front of them while they're being asked to copy this. Here you see something entirely different. Well, not entirely different, I suppose. Here, this person is looking at this, but as they were copying it, they do a fairly good job with the basic structure, but then they get lost in adding their own details and ignoring other details from their actual task. Here, they're not able to maintain task, and they simply just go about whatever they feel like adding. For example, there are no stars in this original image. Now, just one final thing. I believe I've mentioned this somewhere else in the lectures, but your prefrontal cortex, followed by your frontal cortex, is one of the first parts of your brain to become inhibited in the use of alcohol. So this is one of the reasons also why it is so hard for us to inhibit certain behaviors when we have been drinking significantly. Some people have, at least in discussions, have come up with the idea that this could be one reason why many people have this, I don't want to call it a misconception, but this almost folklore style understanding that when people have been drinking, they will show their true selves. Now, if you believe that a person's habits define their true self, perhaps. Ultimately, what's going on is when people tend to drink a lot, this region of the brain is largely impaired, and people are not able to prevent their automatic behaviors from happening. Right? So there are many, many examples of this. People who are generally frustrated and somewhat aggressive will be more likely to throw a punch or a swing after they're inebriated than people who tend to be naturally calm or reserved, who will oftentimes not engage in such violent activities even when they are completely drunk. This is also why people who leave bars after drinking, now please note I am not in any way advocating this because cars are really heavy and you can kill people with them, yourself included, but this is why a lot of times when people are just completely drunk, they're able to drive home without too much of a problem, or they don't get caught at least. Whereas if you were to ask them to drive somewhere unfamiliar, they would probably get into all kinds of problems. This is because they just engage in an automatic behavior, but if they were required to do something new, it would be incredibly difficult for them. Just something to keep in mind. If you need to learn new tasks or you need to keep your wits about you, you probably don't want to be drinking very much. Further, it is important to know, while many of us believe that one drink doesn't really affect us very much, even the first beer that we drink of a low-grade alcohol will impair our reaction times and our brain function. This is true for most other drugs as well.